Hi everyone, Xiwen here from the National University of Singapore, and today I'll talk about our most recent work called PhishDecloaker, detecting CAPTCHA-cloaked phishing websites via hybrid vision-based interactive models. So to begin, phishing websites and anti-phishing entities are in an endless cat and mouse game. So phishers will use a variety of cloaking techniques to deny access to anti-phishing entities and evade detection. Some of the known cloaking techniques include the use of IP and user agent blacklists, or generating one-time URLs for phishing emails, or the use of browser fingerprinting to determine whether or not the visitor is a user or a crawler. Recently, there's a new trend known as CAPTCHA-cloaked phishing, and this is reported by many other security companies and institutions, include Trend Micro, Palo Alto Networks, AT&T, and many others. So CAPTCHA cloaking is quite problematic because of three main reasons. First, it provides a false sense of legitimacy. According to statistics, among top 1 million popular websites, more than 25% of them are using CAPTCHAs for common workflows such as authentication. This will cause unsuspecting visitors to lower their guard when they visit a phishing website that contains CAPTCHAs. Furthermore, CAPTCHA cloaking has a low deployment cost. There are many free or open source CAPTCHA services such as reCAPTCHA or HCAPTCHA that can be easily integrated into websites. And lastly, CAPTCHA cloaking is hard to bypass. Our 7-day empirical study shows that none of our own 500 CAPTCHA-cloaked phishing kits can be detected by VirusTotal, Google Safe Browsing, or Microsoft Smart Screen. Inspired by this, we developed PhishDecloaker, which is a hybrid deep vision system to automatically detect, recognize, and solve diverse CAPTCHAs on phishing pages. You can think of it as a black box, where given a suspicious website containing a CAPTCHA as input, we will try to solve the CAPTCHA and reveal the hidden content that's behind the CAPTCHA. So once this content is revealed, or as we say, decloaked, we can pass it to any phishing detector for further analysis. PhishDecloaker adopts a three-stage approach, where there's a detection, recognition, and a solving stage. In the detection stage, we model the problem as an object detection problem, where given a web page screenshot, we try to find bounding boxes or regions that are potentially CAPTCHAs. In the recognition stage, we take these bounding boxes and crop out all the regions from the screenshot and try to identify the type of CAPTCHA that's present. So once the CAPTCHA type is known, we can deploy the corresponding CAPTCHA solver that uses browser automation to interact with the live page and complete the CAPTCHA challenge. So this is a high-level overview of PhishDecloaker's internal components. So now let's move on to the technical details of PhishDecloaker. In the detection stage, we use a modified faster RCNN, also known as an object localization network. It is trained with only localization and bounding box regression loss and has no information about the type of CAPTCHA. This could help us produce a more generalized detector that can potentially handle unseen CAPTCHA types in the future. And of course, similarly, in the recognition stage, we have several design considerations in mind. As CAPTCHAs contain text and visual information, we have to model the problem as a multimodal representation learning problem. And of course, in the recognition stage, the model also needs to handle different challenge variants among the same CAPTCHA types, known as intra-type diversity. And they also have to handle potentially new and unseen CAPTCHA types, known as intertype diversity. With all these considerations in mind, we propose the use of a deep Siamese model that uses a dual branch architecture, where one branch will process textual features and another branch will process visual features. So given a CAPTCHA image as input, it will encode the image as an n-dimension embedding. Once we have this embedding, we can compare it with a list of reference embedding to find out what is the type of CAPTCHA that's present. We train the recognition model via a metric learning training objective, where we try to pull positive pairs which are the same CAPTCHA types closer and the negative pairs further in the embedding space. We use sub-center arc phase loss as our objective function, where arc phase here implies that the learned embeddings are distributed on a hypersphere with radius of S. This will hopefully address the intertype diversity issue. Subcenter here implies that the embeddings belong to the same class could potentially have multiple clusters. This could help us address intra-type diversity issue. PhishDecloaker is able to handle the solving of 4 different CAPTCHA types: reCAPTCHA, HCAPTCHA, slider-based CAPTCHAs, and rotation-based CAPTCHAs. But due to the modular nature of PhishDecloaker, it can be further extended to support many other new CAPTCHA solvers. For reCAPTCHA and HCAPTCHA, we model the problem as an object detection problem. Whereas for slider-based CAPTCHAs, we model it as a template matching problem where we try to calculate the distance between the puzzle piece and the puzzle gap in the challenge image. As for rotation-based CAPTCHAs, we model it as a regression problem where the model will try to predict the degree of rotation required to reorient the image. And once this rotation is known, we can translate it directly into a drag distance that's required to solve the problem. To understand the practicality of and effectiveness of PhishDecloaker, we conducted a field study to see whether or not PhishDecloaker can help us discover more zero-day phishing websites in the wild. We prepared 6 study groups for our field study, as shown in the table. All study groups uses the same phishing detector, which is phish intention, and each study group has a combination of different features that could help it discover phishing websites. For the first group is a control group with no features equipped. The second group is just the control group with JavaScript rendering enabled. As for the third to the sixth group, each of them is equipped with a type of anti-cloaking technique for it to handle special phishing websites. So PhishDecloaker belongs to the sixth group, which is anti-CAPTCHA-cloaking. To set up this experiment, we crawl new domains from Searchstream in a continuous and automatic manner for up to 4 weeks. And we deploy the 6 study groups on the crawled domains for further analysis. So if a domain is reported as phishing by any of the study groups, we will manually inspect the domain and track some of the metrics associated with it. Following previous studies, we define a phishing website as 0-day if it's not reported by VirusTotal at the time of our inspection. We also record the time to take down, which is the total hours required for the site to go offline, and also the time to blacklist, which is the total hours required to be blacklisted by any of the phishing detectors we use in our empirical study, which are VirusTotal, Safe Browsing, and Smart Screen. So we have some findings available for our field study. And the first, we will look into the PhishDecloaker's overall performance. We find that PhishDecloaker can help us discover 7.6% more phishing websites that are not reported by any other study group. And also, PhishDecloaker captures the most zero-day phishing websites. And if we look into the sectors targeted by CAPTCHA-cloaked phishing websites, we find that it slightly differs from that of ordinary phishing websites. There's some overlap in terms of the sectors, but overall, CAPTCHA-cloaked phishing websites mainly target cryptocurrency and social networking brands. And if we look into the CAPTCHA types used by phishing websites, we find that phishers tend to use free and convenient CAPTCHA services, and it's predominantly reCAPTCHA and HCAPTCHA in our field study. This distribution differs from the CAPTCHAs that are used by benign websites, which has more variety and has more types of CAPTCHAs. And if we look into the CAPTCHA service API keys used by CAPTCHA-cloaked phishing websites, we find an interesting observation. We can extract these keys from the CAPTCHA iframe in in the DOM of the website. And interestingly, we find that the distribution of API key usage is roughly Pareto on the CAPTCHA-cloaked phishing websites. We find that fewer than 20% of the API keys account for more than 55% of CAPTCHA cloaking. So, for example, we discovered that one specific HCAPTCHA API key was found to be reused across 19 different phishing websites. So, because phishers will reuse these API keys, we suggest that they can be used as an potential indicator of compromise for phishing detection. And besides, we also look into the phishing lifespan and the time to blacklist for ordinary phishing and CAPTCHA-cloaked phishing. Surprisingly, we found that CAPTCHA-cloaked phishing actually has a shorter lifespan as compared to ordinary phishing, which is about 9 hours as opposed to 13 hours. However, it takes blacklist-based detectors about 40% longer time, or 11 hours more, to register CAPTCHA-cloaked phishing in their blacklists as opposed to ordinary phishing. We also look into the overhead of PhishDecloaker, and we find that the median time for PhishDecloaker in terms of its detection, recognition, and solving are 0.4 seconds, 0.3 seconds, and 15 seconds, respectively. The long solving time of PhishDecloaker can be mitigated by the use of task priority queues and asynchronous processing. So we can divide the components of PhishDecloaker into individual modules, where there's a crawler cluster, there's a captcha detector and recognition cluster, there's a captcha solving cluster, and a phishing detection cluster. So each cluster can be scaled up and down according to the needs and according to the deployment needs. And that concludes my presentation, and thank you all for listening. If you have any questions, you can shoot us an email. And if you're interested, you can look into our resources, which are publicly available. We have our code base, our data set, and of course, the models used in this research. Yeah, once again, thank you.